In part one of this video, I bought this very inexpensive, beautifully made dowel maker on Amazon for under $50 Canadian. I tried to use it, I did not like it, and I tried to analyze what went wrong in the design of this product, what went wrong in the use of this product. And the main thing is that this brilliant design gave me a lot of ideas on how to advance a dowel maker that I'd already been developing and creating and using in another form. These are two prototypes that I made. The first one is made out of wood, and I started using this and I was getting great results. But wood is just not the strongest thing in the world, and I was getting a little bit of friction, a little bit of burning. I moved on to making one out of solid aluminum. I had this laser cut out of aluminum very accurately based on my own design, and I've been using this, and this is pretty tough stuff. I'm going to show you how this works. Disclaimer, it's based around a router. So unlike this device which has the cutter on board, this one uses a router bit as the cutter. But it does produce very good results. If you have a router, maybe it's something you can start to think about using. Before we do that, I put chapters in this video. You can skip ahead to just see how this is used. We're going to quickly imagine this as a product in the current marketplace, in the current world of dowel making tools. And we're going to see where it might fit. I'm going to go over all the dowel making products I could find, from the most expensive, from the luxury dowel makers, to the least expensive DIY options that are almost pennies to create. And we're going to see, just kind of get a gauge of what the results are from each system. And afterwards, you can think about what would be the price point for this and what you'd be getting from that price. And you can, you're probably already thinking about, how much do I really want to spend on making dowels? How valuable are dowels to me? How many do I make? Think about all those things, and let's go right now, and we're gonna look at all the dowel makers that I could find. The world of dowel making equipment is pretty vast, so let's break it down from the most expensive to the least. If you're running an industrial dowel making business, you're probably using a machine similar to this. The Oliver Dowel Maker Model 7660 clocks in at $9,000 US. And it's almost $500 extra for the cutters, and that's just for one size of dowel. How does it cut? From what I can see, you feed the square stock in a roller, and it cuts and smooths the dowel with a rotating cutter head. It looks very fast. I can't speak to the surface finish. It doesn't look that great in that clip, but it should theoretically be very accurate. However, the industrial dowel making industry is notoriously inaccurate. Home center dowels are often way undersized to their dimensions. So I really hope that if you spend $10K to make dowels, that they're accurate. Coming in at $519 Canadian is the Veritas Dowel Maker by Lee Valley. Now, this is the dowel maker for the discerning dowel maker. Of course, it's going to be good. It's Lee Valley. It has a heavy cast iron body and lots of sizing options. And in their literature, they lead with the main problem it solves is that it's extremely accurate to size. How does it cut? This dowel maker has blade cutters set in a heavy cast iron body, and the user rotates square stock by using a hand drill. And it's actually a 3-stage forming method. The first stage is a rough cut with a blade, and then it passes to a final dimensioning with another blade. And then finally, at the end, the dowel is squeezed through a very accurate steel hole to compress the surface into perfection. The surface and the cut quality looks really good. The surface finish has like a glossy perfection due to the final squeezing and burnishing step. I also just found out that Woodpecker Tools made a dowel maker, and this was a one-time tool. They don't make it anymore. But when it was sold, the retail was almost $400 US. How does this one cut? They use a completely different method. It's actually a pressing method. So square stock is pressed into a steel form. You swap out some inserts and then you can make different sizes of dowels, and even cooler is you can make fluted pegs for internal joinery. And I think that's what this machine is for, actually, internal joinery pegs. This will only make 6 inches of dowel. And I think they envisioned it as that, just carving off these pegs for internal joints. And the surfaces don't look that exciting either. So now we jump down to under $50, and there's the Chinese-made dowel maker. From what I can see, there's at least 50 different companies that have bought the rights to sell this model and slap their own logo on it. How does this one cut? As we've seen already, a drill is used to rotate square stock into a carbide cutter, and the dowels it produces are garbage. And then suddenly we enter the world of DIY, where costs can be almost nothing, depending on what you have lying around. One of the popular methods is a jig based around a table saw, where the table saw blade provides the cutting. So we have different sized dowel inserts that are hand drilled into wood and set into a box. And I've also seen router table versions of this. While you're on the router table, you can also simply carve away all 4 sides of your square with a round over router bit. I've seen this produce very smooth results, but you're limited to what roundovers you have in your collection. The cheapest method is a hole and a blade. I've seen examples of holes with planer blades on angles for different sizes, jigsaw blades, you name it. Now, all the DIY methods have their own specific set of problems. Wood-on-wood friction can easily burn or set fire to your hand-drilled holes. Routing round objects is inherently dangerous. There's also old-school methods like punching wood through a steel plate. I also found an example of an old Stanley dowel maker that works kind of like a big pencil sharpener. And I'm not going to price these methods because they're hard to find nowadays. You can also use a lathe. The problem is that small sized dowels become very unstable when being clamped by a rotational device. And you'd have a really difficult time turning an accurate 1/4 inch dowel that was 4 feet long. So I'm going to leave that out of the equation. Just like any other aspect of woodworking, if you're making dowels, they have to be accurate. A dowel usually fits into a hole, and the dowel has to be accurate to fit into that hole. It also has to look great if you're using it on the face of a piece. So dowel making is its own particular challenge in woodworking. When I first started making dowels, this is the very first jig I made. The first thing I did is I tried it on the table saw. That didn't work for me at all. So I moved over to the router, and that worked really well. And again, it's that standard taking square stock, putting it in through square stock into a larger hole, and then it's cut in here by the router, and then it moves to a smaller hole. This is all made from poplar, so it had a real difficulty standing up to anything harder than it, like oak. This worked well. I would have kept using this, but the one thing that really bugged me is you had to make all these different inserts. So I have all these different inserts for all different sizes. I was losing them. I was losing track of which one to use where. It was driving me nuts, and I really wanted to come up with a simpler version, and it took me quite a while. And it wasn't until I saw this product and saw the clock of different dowel sizes that it really gave me an idea. So I had a problem. The problem was to somehow amalgamate all those different inserts, and I had a number of different ideas, but the clock design from the Amazon product gave me a lot of good ideas. So I integrated my own little clock here, where all the final dowel sizes would be selectable on one wheel, and I could simply turn it and get the size that I want. And the registration for centerline would be through these secondary mounting points. So these are the iris sizes where the square stock goes in, and this is the final dowel size. So when I was making the wooden version, I just simply drew it all out in the computer. I just did this in Photoshop, and I printed it out 1-to-1 and used this as a very accurate drilling guide to hit all those dimensions. Let's take a look at the wooden prototype in action. And here you can see the basic functionality of it, how it interacts with the router table. I'm going to make a 20 millimeter dowel here. So the basic concept is you use the wheel to select what size dowel you want, what size is the appropriate iris for your stock size. Now the main alignment you have to do is getting the router bit right on the side of your final profile. After a couple different attempts at alignment, I was able to get a very precise 20 millimeter dowel in poplar, but I couldn't go beyond poplar. As soon as I started to use oak, the friction from the hardwood caused burning, actually started smoking and caught on fire at one point. It was just like when you're building a campfire and you're rubbing two sticks together. So the wooden prototype actually works great, but the thing is, it's wood, and when you're running oak or hardwood or anything as hard as this is maple, through it, there's friction, it's burning. You can see this hole is just scorched, and it's actually been sort of reamed out a little bit. It's over dimension now, what it's supposed to be. So we move on to aluminum. Aluminum is much harder than wood. Not that much harder, but it's definitely harder, and it's gonna withstand the forces that are put against it. So let's talk a little bit about setup. Basically, like you just saw, it's running over top of the router bit. I've got a GESM router plate here, and it has actually two 1/4-20 mounting points. I'm going to use those mounting points for this demo. There's also, in a future version, there'll be a sidewall here, which will actually stiffen this whole area. And you could just clamp that sidewall to a router fence if you don't happen to have a GESM router plate. And I'm sure many of you don't. There's lots of other ways it could possibly be, there could be mounting points just to raw dog a router on there. You could just have a simple board with a router. There's a lot of options here. So I'm going to put it over the router bit. Now I've already selected 5/8 here on my final dowel wheel, and I've already selected 1 inch, which is the iris size. So that is the square stock size. It works out to just under 3/4 of an inch that fits in there comfortably and rotates well. And it's good to really just take up that space because you want it to sort of keep itself in there. And the more stable it is rotationally, the better the cut is going to be, definitely. So I'm going to put it over top of the router. I'm going to line up the mounting points. And I'll just use this previously made 5/8 dowel to sort of get it in the zone. You can also do this by eye. So I'm basically just going to get it in the zone of what I think would be a good cut. It's better to err on the side of a little bit under. And then I'm going to start doing tests, and we're going to build our way up to the perfect dowel. The way this is all oriented, you could have it on top of the router bit too, and you could be cutting from the bottom. I'm cutting from the side. I've tried the bottom. I tried the side. The side is an infinitely better cut than the bottom. Also with the bottom, when you remove it at the end, you're kind of scraping the bit a little bit, so you're going to cut up your piece. The side, the router bit just kind of falls away, it curves away. So it's a lot easier just to drag it back out. Now, from the bottom, you actually have if you're using a router plate, you actually have your height controls, and you can, this is a pretty luxurious way to dial the whole thing in. When you're going from the side, you have to dial it in yourself. So you're using these slots here to move it back and forth and find the perfect cut. And that's what we're going to do right now. We're going to do a test, and then we're going to work our way up to what we see as the perfect cut. Okay, so I got it in a position that I think is going to be good for the first cut. I've got it as close as I can. And then after the first test, I'm just going to cut a little bit. I'm going to look at it, and then we're going to use an adjustment method to get it in the zone. The most badass way to do this would have this all be on a micro adjuster somehow. That would be so cool. I can't figure out how to do it, not just yet. So I'm going to use this method, which has worked pretty good so far. So I've got my stock prepared. The very first test I'm going to do is with softwood. This is pretty much a scrap piece of 2x4. It's either spruce, pine, or fir. And I've got it kind of carved out a little bit to start it. And I'm also going to drive it, obviously, with a drill rotationally. And I've got these 12-point sockets. I found one that works really well for 3/4, which is 21 millimeter. I kind of punched it on there with a hammer, so it's good and firm. The whole chain of events should be very solid all the way along, and we'll see what happens on this first cut. Now I've got the stock, just a little note about the stock. I've got the stock just a little bit oversized from 3/4, and with softwood, it's so much softer than the aluminum. It's gonna kind of compress actually right on the edges and just really hold that in there firm. I hope it's within that right zone to just keep going without too much problems, but we'll see. Oh yeah, that's stiff. Let's see how this goes. Let's see how it goes. So I just cut a little bit of the piece as an example. Initially, everything looks great. There's no tear out. It's looking good. It's looking like a real prime candidate for a nice light sanding finish. I can already tell it's loose in the hole. We're cutting undersized a little bit. And our target is 0.625 to get exactly 5/8. Actually, it's going to be a little bit, these holes are a little bit oversized, and the idea behind that is if you squeeze it perfectly through this hole, it's a little bit oversized by about 1/64, and that 1/64 is going to be taken away. That's your sneak up zone. So that'll be taken away by sanding. You can sort of massage your fit into your final hole. Okay, so let's see what we got here. So that's 06020. The target is 06300, a little bit oversized from a true 5/8. So there, 0.6300 minus 0.6030 equals, that's the total difference. I'm going to divide that by 2 because there's 2 sides, and it's at 0.013. Okay, so it's 0.013 is what I need to change it. And I need to move everything this way to expand, to create more space and expand the size of the dowel. So I'm going to use a feeler gauge. You have a feeler gauge, don't you? You have a set of feeler gauge. You're a machinist slash woodworker, aren't you? You could just do it by eye if you really want to. Again, that's why a micro adjuster would be so cool in this thing. But anyway, I'm going to take I'm gonna take a block of MDF and I'm gonna put my feeler gauge in there. I'm gonna clamp this down. I'm gonna release this and then move it that little bit to open it up a little bit, okay? Okay, so I've made my adjustment as to what I think will be a lot closer to the perfect cut. And what I'm trying to go for is, it's loose right now. I just want it to just perfectly fill up that space, and even just a little bit over, so it's really squeezed in there. You get the effect of burnishing from rotationally going through the metal. But let's see what happens on this. I can usually hit this within one adjustment or just another minor adjustment, but let's see. Okay, so this looks a lot more firm. Yes, there is some, once it gets going, once you get it perfect, ooh, there's a little bit of burning there, but that's easy peasy to get off with sanding. The main thing, no tear out. Oh yeah, so we're at 06375, that's actually big. I'm gonna back it off a little bit, actually. It was getting hard to get it through. Third attempt is on the calipers. These friggin' calipers. It's 06310. That is just above where we want it. It's really jammed in there. I would like that a little bit easier to go through, to bring it down to 300, but that's pretty good for a test. Still a little bit of burning, significantly less now. Again, that can be taken off with the fine sanding when you bring it right, when you sneak up on that final at the end. I've done my adjustments. I'm pretty confident that the final result is going to be good. It's going to be just coming out of that hole, and the dimension is going to be where I want it to take it to the next step afterwards, which is just sanding and final fitting. I got everything cleaned up. Let's try one. I just got a 2-foot dowel. Again, I'm still on scraps here. I just keep testing it till I get it really good. It's all locked down and I'm confident, and then I can just run as many as I want. You have to do this with every system, even with the Veritas dowel maker. There's a ton of tweaking involved to get something of good product, and then you start using all your good wood. But first you're just kind of working with scraps a little bit. That is 6,310, 315. So that's good. That gives us that 1/64th to sneak up on 06250, which is true 5/8. And again, you're fitting it into a hole at the end of the day. So you want just that little bit of wiggle room. I think the inside of this hole has become a little dirty. I think this wood is just generally dirty too. I've definitely got much cleaner results, but that's easy to sand away. The big thing, no tear out. Pretty smooth all the way down, and a little bit of light sanding will heal that. It's always the fun part, is getting this thing out of here. It's good to leave a square part. Obviously you're gonna have a little bit of square left, But don't cut it off right away. Leave a little bit of the square part, and because you're gonna want to use that same thing for sanding. Let's just sand a little bit of it here. It's not burning. This is a little kind of a bit of a gray piece of SPF. Man, that is just really smooth. I'm not seeing any flaws. And we had 6310 when we first cut it with the router. And now, now we're down to 6290. So we're getting there. We're sneaking up. Here's a 5/8 hole with drilled with a Forstner bit. Yeah, and that is just that's that tight fit that we want. So that's good already. I'm kind of forcing it in, I'm kind of burnishing it in. And again, that just gives me that little bit of tweak, that little bit of extra that I can sneak up on. And no, I'm just a touch oversized so I can sneak up on it and get to that perfect fit. And the main thing is that all the cutting is working well. Okay, so let's just go back in time and compare this to, the shadowing isn't great here, but let's compare this to the dowel with the Amazon dowel maker. Obviously, you just can't heal a surface like this with sanding, right? So with the router, with my prototype, it's pretty nice. There's no tear out. And again, you've got that extra little just to sneak up on with the sanding. Any surface texturing. Surface texturing can come from everything just bouncing around and it slamming into the router bit a little bit too much, but it's pretty minimal. And this happens when it forms a great stable connection with the unit and it's moving through rotationally very stably. So you can get a very smooth surface to begin with. You can make it even smoother with sanding, and you have the ability to sneak up on it. That's the main thing. Okay, I'm gonna get killed in the comments, but I actually, now I use this to create. I'm using 16 millimeter, which is close to 5/8, to make my starting cut, to shape it. So this did end up being useful after all. Good job. I'm gonna do a victory lap with one more piece of softwood here, and then we'll move on to hardwood. Okay, that was good. This is the stuff that dreams are made of. This is really nice. The surface finish isn't dead on perfect, but there's no tear out. You've got the dimension to sand away to your final dimension. You've got everything you need from this piece. This is a good, solid dowel. And there's no burning this time. I think that just the cleaner wood did wonders for the whole system. So now the main event, hardwood, and this piece of oak, not this specific piece of oak, but oak in general, is what defeated the wooden system. It killed it dead with burning. The thing caught on fire, it was crazy. I'm gonna add dust collection on this one. This system, sort of just the way the router bit is cutting, it's sending all the chips just spraying this way. Makes a lot of mess. I've got this old router fence dust collector hoodie thingy. I'm gonna double-sided tape this over here, vacuum hose, and it'll get a lot of the dust. It's not a very good mount, but that could be figured out later. I'm big on dust collection, and I think this should be integrated into this somehow. It's not too hard to do, but I'm just gonna add this on right now. This was just a little bit too firm for my taste. I'm gonna back it off by 0.005. That was so squeaky. Okay, I think future iterations are gonna have to have anti-squeak technology. And I can just coat everything in wax. Let's check the dimensions. 6315, so that's it exactly. Weird, I backed it off, yeah, and it still hit that same dimension. Again, I'm just going in with 150 grit, and really that's all it needs. It doesn't, you don't need to start off with any aggressive grit. It's just the final touches. I'm just holding the sandpaper in my hand, and it seems to always do a great job that way. Okay. Could be a bit smoother actually, but yeah, that's just more sanding. Oh, 0.6285. Yeah, so that's, we're in the zone. Yeah, so that's good. We're in the zone. We're in the sneak up zone. There's just that 1/64th left that you can have in your pocket to play around with to get that perfect fit. Okay, that was a lot, but we got there. Thank you for watching this far, if indeed you are watching this far. My main question, my main point in making this video is, would this be a good product? How much would you pay for this? Me personally, if this was brought up, if I knew that this worked, I knew it was going to produce flawless dowels, and this was brought up to the same fit and finish within within certain parameters of this. If it looked good, it worked, etc., I wouldn't hesitate to pay $100 for it. If I saw it listed for $100 and I knew that, boom, it was going to work, I would pay that much. I want to hear from you what your tolerances are, what your experiences with dowel making are, and I just want to pick your brain a little bit. So thank you. If you could leave anything in the comments, that would be very much appreciated. I'm so curious as to what other people's experiences are. Also in the comments, is there any other machines that I missed? Is there any other methods of making dowel? I feel like I got a really good overview, but there's always just something hiding in the shadows that I hadn't thought of. How are you making your dowels? Did you just buy them? Do you have some other bizarre system that you made? Let's talk about that too. Thank you for watching this much, and thank you.